myself Dr. Priti Jagwani. I am from Department of Computer Science, Aryabat College, University of Delhi. So in this lecture series of computer networks, in my previous lecture we looked upon the functionalities of the network layer. Then we have gone through some of the protocols which are being used on this network layer, and finally we also looked into some of the routing algorithms. Now that was all for network layer. Now moving on to our next module, or we can say our next chapter in this particular lecture series computer networks, we are landing upon the transport layer. So the transport layer is actually which is, we can say, built on the top of network layer. So when we look into the network layer, please recall that network layer provides end-to-end packet delivery using datagrams or virtual circuit. Now transport layer, which is on the top of the network layer, is actually, or we can say, the basic duty or the basic responsibility of the transport layer is to provide data transport from a process on a source machine to a process on a destination machine. Now why I am saying from a process, because there is a special significance of this processes in the functionality, or we can say in the working of transport layer. Now it is not just kind of providing data transport from a process on a source machine to a process on a destination machine. This data transport should be done with some requisite level of reliability, and that reliability should be independent of the physical network which is kind of being used currently. So desired level of reliability, and with that reliability, data transport from a process on a source machine to a process on a destination machine is what is building the bottom line of your transport layer functionality. Now this transport layer also provides the abstraction that the application need to use the network. And without transport layer, the whole concept of layered protocols which we have seen in our OSI model is not going to make much of the senses. So ultimate goal of the transport layer, if we want to we can say sum up in a nutshell, is going to provide efficient, reliable, cost effective data transmission services to its users, which are now when I am saying to its users, that means normally which are the processes in the application layer. So the ultimate or the end goal of the transport layer is to provide efficient, reliable and cost effective data transmission services to the processes which are residing to the processes in the application layer. Now when we say a transport layer, it is building onto the network layer. So in order to achieve its functionality, the transport layer, as per the we can say characteristics of the OSI model, the transport layer will definitely make use of services provided by the network layer. So every layer at the bottom is going to provide services to the layer on its top. The software or we can say hardware within the transport layer does which is going to do this work, that is what we call is transport entity. So basically usage of the services provided by the network layer is done with the help of, or is done by transport entity. Now as we have seen that there are two types of network services. When we were reading this network layer, we have seen that there are two types of network services. One is connection oriented and another one is connectionless. So there are also two types of transport services also on the similar lines. We have connection oriented transport service, which is similar to the connection oriented network service in many of the ways, we can say, and the connection less transport service, which is aligning with the connectionless network service. Both the cases, whether it is going to be a connectionless or it is connection oriented service, connections basically have, you know, three phases. One is the establishment phase, another one is the data transfer phase, and the third one is the release phase. Now, apart from the types of services which are connection oriented and connectionless, the addressing and flow control are also, you know, we can say similar in both the layers. So, which layers I am talking about here? I am talking about network layer and of course the transport layer. And I have told you the connectionless transport service is also very similar to the connectionless network service. Now, one question which, you know, definitely comes up in the mind, that when we are saying that similar type of connections, similar type of services like connection oriented and connectionless on both the you know, layers, then addressing and flow control again kind of, you know, we are saying similar in both the layers, then why do we need two separate layers for the similar functionalities? Why is not one layer, you know, kind of adequate or enough for this kind of functionality? So, the answer is that the transport code runs entirely on the user's machine, but the network layer mostly runs on the router which are operated by the carrier. So, actually it is the, you know, what we can say, where they are, you know, getting operated is something which is going to, you know, create a line of difference. Transport code is running entirely on the user's machine, but the network layer mostly runs on the router. So, that is why one layer is not adequate for the similar kind of functionalities, but at the different places in the network we need two different, you know, layers to handle it. Now, when we say transport layer, this transport layer ensures end-to-end communication between the applications on, you know, different kinds of hosts. So, basically your transport layer, if we look into the you know, we can say positioning, it sits between the network layer and the session layer as it is being shown in the figure. So, at the top we have application layer, then we have presentation layer, session followed by session layer, and then there comes transport layer, and at the downside of the transport layer, or at the lower side of the transport layer, we have network, data link and physical layer. So, your transport layer basically lies between the session layer and the network layer. So, this is what the positioning of transport layer in OSI model is. Now, it sits between the network layer and the, you know, job of the network layer is to deliver the packet to the right machine, and the session layer. So, session layer, when we say, you know, in short, that session layer manages communication sessions, as the name indicates, session layer. So, the, you know, the main job of the transport layer is to deliver the data reliably, efficiently and in correct order. Now, you know, let us look at the, you know, working of transport layer. Now, transport layer, when we say, it is implemented only in end system, not on the intermediate routers, as the network layer was like network layer. So, here is the difference which we have already seen, that it is implemented only in the end systems. Then it uses the port numbers to identify sending and receiving applications, because your, you know, transport layer is actually dealing between dealing with user processes, users. It requires port numbers to identify which applications are sending the data and which are the applications which are ready to, you know, or which are the applications which will receive the data. It is going to use port numbers as the identifications. Then it supports process to process delivery, which essentially means that multiple applications can share a single network connection. And how this is done? This will be done with the help of multiplexing and demultiplexing, which will, you know, which we will be looking into in a detail in a short while. Then for this process to process delivery, it performs multiplexing and demultiplexing using port numbers to direct the correct data, or we can say to direct the data to the correct processes. Now this data is divided into the segments which are TCP segments if it is being used, if TCP is being used, or the data from the upper layers will be divided into datagrams if the UDP is going to be used, and it necessary headers are being added over here. Now when I am saying say segments, which is kind of a smaller data bundle or a smaller data unit for TCP, and the datagram, which is a smaller data unit for UDP. Now here comes a difference, one of them is connectionless, another one is the connection oriented. This also we are going to look soon. Apart from this, your transport layer handles error detection, retransmission and sequencing also to maintain the communication in a reliable manner. So not only the flow control, but the error detection, retransmission and sequencing is also done by transport layer to maintain reliable communication, and it, as I have told you, it coordinates the flow control to ensure that the receiver is not overloaded. Then it also communicates with the network layer, and the network layer is supposedly handle the addressing and the routing. At the receiving end, it removes the headers, reassembles the data and passes it to the appropriate application. So at the sending end, it takes the data, convert it into either the segment or the datagram, depending upon TCP usage or UDP usage. It is going to add some headers onto it, after ensuring the flow control, error detection, retransmission and sequencing. At the receiving end, it also removes those headers which are added onto the these segments or datagrams on this sending end. Then it reassembles the data and passes on it to the appropriate application. So this was, we can say, a working when we look into kind of in the working of the transport layer in a brief manner. In order to achieve this whole process, or in order to achieve this whole workflow, there are so many functions which are to be provided by or which are to be done by the transport layer. So let us look into what are the functions of transport layer. So transport layer, as I have told you, that it is responsible for end-to-end communication of data packet. Apart from this, it is important for so many variety and crucial and critical functions like reliable, efficient and organized sequential data transfer between the host systems in a networked environment. So this is what we can say the functions of transport layer in a brief. But when we look into the details, the primary functions of the transport layer are so many. So the first one we can say end-to-end communication between the host. So your transport layer is responsible for creating end-to-end connection between the host, for which it is going to use either TCP or UDP. Here is a figure which is kind of giving you an idea about the end-to-end communication with the help of either the connection oriented service for which TCP is being used, or the connectionless services for which UDP is being used. And both of this connectionless and connection oriented services are having their own kind of applications or usage scenario in which one is preferred over another. So end-to-end communication between host is one of the we can say important functionalities or important functions of your transport layer. Apart from this end-to-end communication, one major responsibility comes as in the form of flow control. Now flow control mechanism is provided by transport layer between the adjacent layers of TCP/IP model, or we can say OSI model also. TCP also prevents the data loss due to a fast sender and the slow receiver by imposing some flow control technique. So, your flow control essentially means that a fast sender should not keep your slow receiver in an overwhelmed situation. Now, for this flow, in order to control this flow, one of the methods or one of the technique which is being used generally is a sliding window protocol, which is accomplished by the receiver by sending a window back to the sender, informing the size of the data it can receive, and as per the communication by receiver, the sender will be able to send the sender will be able to send the data of the size which can be received by the receiver, and that data size is being communicated with the help of sliding window protocol. And this sliding window protocol, if you remember, we have kind of seen in detail when we were looking into some basic protocol. So, TCP/IP model, if we talk about, it is the second layer, transport layer. But if we look into the OSI model, it is actually the fourth layer. But the functionality remains kind of, we can say similar in both of the models. It is an end-to-end layer used to deliver message to a host. Now, when we say it is an end-to-end layer, so this is a specific term which we have not used much in the other for other layers. So, this transport layer is termed as an end-to-end layer because it provides a point-to-point connection rather than hop-to-hop connection. So, hop-to-hop connection is not the responsibility of the transport layer, it is the responsibility of the lower layers. But when we say about point-to-point connection, so point-to-point connection is being provided by your transport layer. This point-to-point connection is being achieved between the source host and the destination hosts in order to deliver the services in a reliable fashion. So, when we talk about the unit of the data in which the data is encapsulated, at the level of transport layer, it is going to be a segment or a datagram, as we have kind of seen till now. Apart from end-to-end connection between the host and the flow control, one important functionality which comes up here, we can say in the account or in the kitty of your transport layer, is about multiplexing and demultiplexing. So, multiplexing, when we say, it is kind of many to one, and it is being done when the data is acquired from several processes from the sender and merged into one packet along with that packet header, and it is being sent onto the network as a single packet. So, this process we generally call it as the multiplexing, and this multiplexing allows the simultaneous use of different processes over a network that is running onto a host. And this is this is actually the reason that at the inception of this lecture I was talking more about the processes, because your transport layer here is going to deal into the processes. So, multiplexing allows simultaneous use of different processes over a network, and that is a network which is maybe running on a host. Now, how these different processes are differentiated? So, here comes the we can say concept of ports. The processes are differentiated by their port numbers. So, multiplexing is done. At the other end, the reverse process, which is demultiplexing, which essentially means one to many, is required at the receiver side when that message which arrives as a single data packet at the receiver's end is to be distributed into different processes, because that particular single unit of data packet is containing data from different processes, and at the receiving end it has to be we can say deassembled, and then that data is to be distributed into different processes. So, this is what we call as demultiplexing. Transport layer receives the segment of data from the network layer, distributes and delivers it to the appropriate processes running on the receiver's machine, and that is why we call that this as a we can say end-to-end machine. So, in order to give you a fair idea about the multiplexing and demultiplexing, here is a figure in which there are kind of two sides of this figure, if you can observe, are source and destination, and then there is kind of some applications which are running onto the source side, taking data from all those applications, bundling them into a unit with the help of multiplexing, and then that data is kind of sent to onto the network. Now, after traveling onto the network, if you can see on the other side, which is the receiver side, that data is again kind of separated into all those three applications. So, the three applications taken here, the three example applications taken here are Gmail, Outlook and Yahoo. So, all these kind of applications are now the data from these applications is separated and now handed over to all these three different processes with the help of demultiplexing. So, multiplexing and then demultiplexing at the receiving end. So, this is also we can say is the job of your transport layer. Moving further, establishment of connection. So, when two devices in a network want to establish the connection using the TCP, because in UDP this process is not required. So, here I am particularly talking about TCP. So, establishment of a connection using TCP is done through kind of we can say that process is known as three-way handshake process. Now, what is there in this three-way handshake process? Let us look at this. So, this three-way handshake process is something of this sort. On one side we have client ports, on the other side we have service ports which is enabled in TCP server. On the TCP client side we have client ports, then there is kind of some synchronization, then some acknowledgement, then again some acknowledgement. If you can see this three processes of these handshake of the three-way handshake process. Now, let us try to understand that what is this sync, ACK and again ACK fields or flags we can say. So, handshake in order to complete the process of handshake, the first computer connects to the second computer by sending a SYN synchronized packet onto a specific port number obviously. If the second computer is listening, it will respond with a sync or ACK as in acknowledgement. It will respond with a sync or ACK flag or field we can say. When the first computer receives this response in the form of sync or ACK, it will replies with an ACK packet, and after this the two devices can kind of we can say communicate normally. So, this process is majorly or this process is commonly known as the three-way handshake process, in which the first computer sends sync, second computer responds back with sync or ACK, then the first computer will replies with an ACK packet. Now, this was establishment of the connection, that is fine, but after the data transfer how this connection is going to be terminated. So, in a TCP scenario or in a TCP connection, there can be two type of termination mechanism for this TCP connection. What are these two types of termination mechanism? One is the graceful connection release, another one is the abrupt connection release. So, in the graceful connection release, the connection is open until both parties have closed their side of the connection, while in an abrupt connection release, either one TCP entity is forced to close the connection, or one user closed both directions of the data transfer. So, that is what your kind of abrupt connection release is there. Apart from this, as I am telling since inception, that reliable data delivery is also a responsibility of transport layer. So, the transport layer checks for errors in the messages coming from the application layer at the kind of sending site, and this is done by using so many error detection codes which are available and by computing checksums. It also checks whether the received data is not corrupted and using ACK and NACK services to inform the sender if the data which is arrived is whether the data has arrived or not, and also it checks for the integrity of data. We have seen so many functionalities of transport layer. So, let me sum up this lecture. We have started from what actually transport layer, what is its position in both of the models, TCP IP and OSI model. Then we looked into what is the basic working of that, and finally we looked into so many functionalities of your transport layer, which is end-to-end connection, termination as well as establishment, flow control, multiplexing and demultiplexing, connection establishment, three-way handshakes, connection termination, reliable data delivery also. Limitations and much more onto this transport layer in the upcoming lecture. Here is a list of references which is being used for the preparation of lecture. I will see you in the next one. Till then, take care. Goodbye.